Good morning, guys. Anjani Kumar here, dealing instrumentation subject for final year electrical students. So, in this session, we are going to deal about the statistical analysis of random errors. Right? We are going to deal about very important concept. Right? Statistical analysis of very important concept. So why we are using a statistical analysis means, you know about it. There is no particular reason. There is no particular reason for this type of error. You just need to eliminate this error. Right? So you don't have any choice. You don't have any methods to reduce this error. So we have some sort of methods implemented from our future scientists, from our past scientists. So those are statistical analysis. In order to reduce this error, you don't have any choice to eliminate. You just want to reduce this error. So with the help of statistical analysis, in this you have 10 or 12 formulas. So you just want to see. So while solving the problem, it will be very useful. Right? The first formula. There are statistical analysis. There is a formula based things. The first one is, what is a mean value? What is a mean value? So mean is nothing but, it can be denoted by x bar. So that is nothing but x1 plus x2 plus x3 plus and so on plus xn by number of readings. Alright? So what is the mean value? If you are doing the instrument, you will get the readings like random errors. These are randomly. How to eliminate, how to reduce these random errors means you have to take the mean value. That means number of readings, x1, x2 reading, x3 reading and so on, xn readings, but how many number of readings. With that you will get the mean value. Alright? After second one is how to find the deviation. Right? A deviation. So D, it can be denoted by, suppose if it is a D1, if you want to have deviation, D1 deviation, so you have to take the x1 minus x bar. Right? If you want to find the D2 deviation from the mean value, see, you don't want to analyze, you just see the formulas itself. So with that you will solve the problem. So if you want to find the deviation in first measurement, you have to take x1 minus x bar. D2 means x2 minus x bar. Right? And so on. Dn means xn minus x bar. You know x bar. X bar is nothing but the mean value. Right? And after that, third one, mean of deviation. Mean of deviation. So it can be denoted by d bar. So mean of deviation, d bar. So you have to calculate. You know about d1 plus d2 plus d3 mod d3 and so on dn by how many readings, number of readings. This is called mean of deviation, or we can call it as a average deviation. Alright? So statistical analysis means which is a formula based to reduce these random errors. So the first one is a mean value. So what is a mean value? What are the readings? x1, x2, x3 and so on, xn by n. So what is a deviation? So deviation from first deviation means x1 minus x bar. D2 means x2 minus x bar. Dn means xn minus x bar. Now, what is the mean of deviation? Mean of deviation means difference, right? Mean of deviation or average deviations means d1 plus d2 plus d3 and so on dn by n. I hope you understand. I'll go for another formula. Right? Now, from here, little bit tricky formulas is there. You have to analyze, right? So first one is a standard deviation. And the fourth one is a standard deviation. right? It can be denoted by sigma value. Standard deviation, it can be denoted by sigma value. So it is sigma n, sigma I is equal to 1 to n di square by n minus 1, right, where n less than or equal to 20. So in about a di, if it is 1 means d1 square plus d2 square. If I is equal to 1 to 2, for suppose I is equal to 1 to 4 అనుకోండి. So I is equal to 1, so d1 square plus d2 square plus d3 square plus d4 square by 4 minus 1. So up to now you have to calculate. If it is n less than 20, right, this is the formula. If n greater than 20, what is the formula? Standard deviation, square root of sigma I is equal to 1 to n di square by n only. You don't get n minus 1 for n greater than 20. Right? So this is a standard deviation. Now the fifth formula is variance. Variance. You don't need any definition for all. Definition also you don't require. The variance, it can be denoted by v. So it is gamma square. Right? So what is the variance formula? It is a gamma square. Right? Next, what is a precision index? Precision index, it can be denoted by h value. Alright, the precision index, it can be denoted by h value. So what is a precision index means? Precision index is nothing but height value. It is nothing but height. For suppose if it is a plus sigma, if it is a minus sigma, right? So this is a height value. So this we can call it as a h value, right? If sigma increases, for suppose if sigma increases, right, what is my height? Height is going to be reduces. If sigma increases, height is reduces. So that means my h precision index is inversely proportional to sigma. Sigma means standard deviation. If you know the standard deviation, with that you can find the precision index. So exactly what is the formula for precision index means? H is equal to 0.707 by sigma. So this is actually formula for precision index. In this you derive the expression for a standard deviation. It can be denoted by sigma. So that is square root of sigma I is equal to 1 to n di square by n minus 1. If n is less than or equal to 20. If n is greater than 20, sigma I is equal to 1 to n di square by n. So what is a variance? Variance means sigma square. So what is a precision index? If you know the sigma, you can easily calculate the precision index. So precision index means height. It is nothing but height value. So h is equal to 0.707 by sigma. And 3 more formulas is there. So with that we will conclude this statistical analysis. Alright. So you just want to by heart these formulas, right? You don't want any derivations and all these things, right? And after that, probable error. So what is a probable error? So what is a probable error? So it can be denoted by gamma value is equal to 0.6745 sigma. So if you know the sigma value, you can derive any formula, right? Each and every formula is derived from the standard deviation itself. If you know the sigma, you can derive any number of formulas. So what is a probable error? It can be denoted by gamma. So what is the value? 0.6745 sigma, right? So what is the mean of probable error? Mean of probable error. So mean means gamma m. So gamma m. So what is the formula? Gamma by square root of n minus 1. You know the gamma. Gamma is equal to 0.6745 sigma by square root of n minus 1. So with that you can calculate the mean of probable error. Right? Now Mean of standard deviation. Mean of standard deviation. That is nothing but mean means sigma m. So it can be denoted by sigma by root m. Right? Mean of probable deviation. You know probable error, gamma. Mean of probable error, gamma m. Standard deviation is sigma. Mean of standard deviation is sigma m. That is equal to sigma by root m. Now we'll derive what is the relationship between standard deviation of standard deviation. Standard deviation of standard deviation. So this is the last formula you have to by heart. Sigma sigma, that is equal to sigma by root 2n. So standard deviation of standard deviation, it can be denoted by sigma sigma. So that is called sigma by square root of 2n. Sigma by root 2 into root n రాయొచ్చా. సో సిగ్మా బై రూట్ n ఏమంటాం మనం, సిగ్మా m రాయొచ్చా. రైట్. సో యూ కెన్ కాల్ ఇట్ యాజ్ a sigma m by root 2 రాయొచ్చా. రైట్. సో ఫ్రమ్ దిస్ యూ know the relationship. Sigma m is equal to sigma m. What is sigma m? Mean of standard deviation is equal to sigma sigma. Sigma sigma means standard deviation of standard deviation. Right? Sigma is nothing but standard deviation. Sigma sigma means standard deviation of standard deviation into root 2. So this is the final formula. Right? So this is the formulas, right? What is the probable error? Probable error, it can be denoted by gamma. So that is nothing but 0.6745 sigma, right? So mean of probable error means gamma m. So that is nothing but gamma by square root of n minus 1. Mean of standard deviation, it can be denoted by sigma m. So that is nothing but sigma by root n. Standard deviation of standard deviation, that is nothing but sigma sigma. So that can be denoted by sigma by root n. If you derive the equation like this, you can, you know the formula for sigma by root n is equal to sigma m. So if you substitute it, you can get sigma m. So that is not mean of standard deviation is equal to standard deviation of standard deviation into root 2. Right. So these are the formulas. So these are the formulas. I'll once again explain you guys the formulas. What are the formulas that we derived till now? The first one is a mean value. So mean value, and second one is a deviation value, and third one is a mean of deviation, d1 plus d2 plus d3 plus d4 and so on by n. After that, what is the standard deviation? Sigma I is equal to 1 to n di square by n minus 1. What is the variance? Variance is nothing but sigma square. So what is the precision index? Precision index means height of that measurement. So what is that height? H is equal to 0.707 by sigma. If sigma increases, my height is going to be reduced. So you will see here. If sigma goes on increases, my height is going to be reduces, right? And after that, probable error. So what is the probable error? Gamma is equal to 0.6745 sigma. Mean of probable error can be denoted by gamma m, that is equal to gamma by square root of n minus 1. Mean of standard deviation, sigma m, sigma by root n. Standard deviation of standard deviation, sigma is equal to sigma by root 2n. Alright, it can be overwrite like this, sigma m by root 2. You can last get the equation. This is a gate question. Definitely in a gate itself you will get the question. What is the mean of standard deviation? Root 2 by sigma sigma, root 2 into sigma sigma. Like that they'll ask, right? 2 or 3 times we got this type of question in your gate examination. Alright, so with that we completed the statistical analysis of random errors. In the next session we'll solve one problem. So with that we'll finish total error concept. Alright, thank you very much. In the next class we'll solve a problem on statistical analysis of random errors. Right, thank you.